The purpose of this video is to explain the terms that we're going to use when we talk about sets and some of the notation that we're going to use. This is a good opportunity to get these things into your notes at a time where you can stop the video and have sufficient time to write them down. So let's begin. A set is a well-defined collection of 0 or more, and yeah, it can be 0, objects, numbers, or other things. The things in a set are called elements. So here's some examples. First, the set 1, 2, 3, 4, 6, 12. Those are the set of factors of 12. David, Joel, Barbara, and Leonard. Those are the set of names of my immediate family members, and each one of those names is an element of that set. The set 2, 3, 5, 7, 11, 13, 17, 19, and so on, that's what the dot 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 means, is the set of prime numbers. The set Ford, Buick, Nissan, Honda, Volvo is the set of car brands that I've owned, and vanilla, chocolate, coffee, peach are the types of yogurt I like. All of those things are sets. A subset of a set is a collection of 0 or more elements from that set. So let's take the set A, and we'll call the set A the set of onions and mushrooms, and those are the toppings that I like on pizza. The subsets of set A would be these 4. Onions, that's a subset of A. Mushrooms, that's a subset of A. The set onions and mushrooms, that is a subset of A. And the empty set is a subset of A as well. The set of no onions and no mushrooms, kind of. Okay, so the entire set is considered to be a subset of itself. So that's the onions and mushrooms. And the empty set, which we note this way, is a subset of every set. So if I ask you for a subset of a particular set, you can always be correct if you say the empty set. So if we take the set A as an example to be the set 1, 2, and 3, we can list all the subsets of A this way. The empty set, the set containing 1, 2, 3, those 3 sets, then the set containing 1 and 2, the set containing 1 and 3, the set containing 2 and 3, and the set containing 1, 2, and 3. Those are all the subsets of A. So I'd like you to take these 2 sets, set A equals D, L, and S, which are my initials, and the set B, 1, 6, and 28, which are the first 3 perfect numbers. And I would like you to write down all of the subsets of each of those. And I'm going to ask you to stop the video, copy the sets and the subsets that you write down into your journal, and then we'll take a look at them after you restart the video. Please stop the video now. Okay, for the set A, which is D, L, and S, the subsets are the empty set, D, L, S, DL, DS, LS, and DLS. For the set 1, 6, and 28, the subsets are the empty set 1, 6, 28, 1, 6, 1, 28, 6, 28, and 1, 6, 28. We use the subset symbol that looks like this to indicate that one set is a subset of another, or to kind of ask a question about that. So we could use this notation in the following way. If we write T is a subset of W, we could be saying T is a subset of W, or we could ask a question. Is T a subset of W? In other words, take a look at set T, take a look at set W, and determine if T is a subset of 0. So here we have 3 sets, A, B, and C, and we're going to ask these questions. Is B a subset of A? Is that true? Is A a subset of B? And is C a subset of A? So we'll take the first one. Is B a subset of A? Well, everything in B is also in A, so B is a subset of A. That's true. Is A a subset of B? Well, let's take a look. Is everything in A in B? Nope. 2 is in A, but it's not in B. So A is not a subset of B. That's false. Is C a subset of A? Is everything in C also in A? Well, no, that's not true either. So we say that C is a subset of A is false. Now, writing sets. So far you've seen me write sets like this. We have a curly brace, and then the members of the set, the elements in the set, and then a closing curly brace. The set of natural numbers less than 10, or less than or equal, well, less than 10, we'll have to correct this, I guess. Okay, there we go. So, set of natural numbers less than 10 is this set here. The set of whole numbers, 0, 1, 2, 3, dot, dot, dot. This means continue the pattern. And the set of integers, and we see that this pattern goes both ways. So integers go -1, -2, -3, and so on. And they also go 0, 1, 2, 3, and so on. So those are all the sets of integers. When we write members in a list like this, we are saying that we write the set in roster form. Roster is a list, and when we list the members of a set, we've written it in roster form. And I guess I have to correct this slide too. Okay. Now, what I'd like you to do is fill in the blanks. There's a description of a set, and then the set is written in roster form. And I'd like you to complete this table. So, where it says factors of 15, I'd like you to write that set in roster form. And then, given a set in roster form, I'd like you to find a way of describing it. And the same go with these. So, stop the video, copy this table into your journal, take a moment to solve all of these, and then check your solutions by restarting the video. Okay, so factors of 15, we'll take a look at what they are. They are 1, 3, 5, and 15. So that would be the correct answer in roster form. These subjects, there are probably many answers that you could have written down. The one that I chose was General Studies subjects at Solomon Schechter Day School. So that's how you would describe that set. Positions on a baseball team. You might have written something like this: pitcher, catcher, first base, second base, third base, shortstop, right field, center field, left field. You didn't have to write them in that order. Any order is okay. And then this final one is the set of perfect square numbers. 2 squared, 3 squared, 4 squared, etc.